Today's focus will be on more about solar panels. All right, so one thing you want to know about solar panels is the conversion efficiency. And basically what the conversion efficiency is, compared to the solar amount of energy that hits the cell or the module or the array, whatever, how much power is actually produced. And in the first stages of these PV cells, these photovoltaic cells, we only had 1 to 2% efficiency. So that meant for every ray or set of rays, only 1% of the amount of energy that it took in, it would release and be able to convert into actual electrical energy. At now, what we're about for most commercial and residential, we're about 15 to 20% efficiency. The most advanced ones, talking about like the NASA ones and things that are used in the solar system, are anywhere between 24 and 45%. So that means, once again, we're not extremely efficient with this. You want to be at 100%, meaning every single thing of energy that the sun hits, it will be then directly converted into electricity. All right, so you will have to know this as far as the order goes, and this is how a a photovoltaic array is made up. Okay, so first you have the little cells, and these are these little guys. You put a bunch of cells together and you get a module. You put a bunch of modules together and you get an array. What we think of as an array is a solar panel. Okay, so if you actually look close at a solar panel, you would see within that you would have these individual little modules, and within the modules you would have these individual cells. And if you put a lot of arrays together, you have, or solar panels together, you have what we call as an array field. Okay, so here's an example of an array field. So you just see a bunch of solar panels put together. Remember, your best bet is if those are able to move and track the sun so that it is always focused on where the sun's at. So all of the energy that the sun's releasing is hitting it directly for the solar panel. All right, so let's put in order from largest to smallest. We've got the array, the cell, the module, and the array field. So what is the largest? That would be an array field. Array fields, remember, are a bunch of solar panels put together. Then you would get an array. What we think of it as array is a solar panel. So that would be our array. And within the solar panel, if you look closely, you will see a module, and within there, you will see your cell. All right, so this is basically when you have it hooked up to a house, what you would get. So you have your solar array or solar panel on the house, and what happens is it absorbs the energy done by the sun, and it's converted into, it's moved in, all that electricity is moved to the charge controller. And the charge controller will either go directly to DC lead, which means it goes directly into running your toaster, running your lights, whatever. But typically what will end up happening is that it will be stored in a battery. Okay, that battery will store your energy. This is where you want a good battery that can store as much energy as possible. Why? Because when the sun is no longer there, then you'll at least have stored some of that energy so you can go and use that energy to turn on your lights, use your toaster, things like that. Okay, so then you'd have the battery then goes to an inverter, and then you use your AC load, which is where it's the alternating current, the things that you plug into the walls of your house and things like that. All right. One positive about solar panels is that it is ideal when you're not a part of the grid. Okay. So where you're not a part of the grid, meaning where you're not hooked up to something that runs off of a power plant, basically, or the transmission lines. Where are you not a part of the grid? That would be on like mountainous areas, or out at sea, or out in outer space, or when you're doing road construction. So if you ever look on the sides of the roads where they have lights or signs where they have messages reading to you, if you look above it, a lot of times they will have these little solar panels, and that's because there's no electrical outlet that these things can be plugged into, and they're not going to be running off a battery, just straight out battery juice. What they're going to be doing is they're going to be using the solar panels to use that solar energy and convert it into use a battery, store that energy, or go directly into producing the signage or the lighting up or whatever it needs to be doing. So that's a great part about solar panels, is that you don't need to be converted, you don't need to be directly connected to a power plant or transmission lines. All right, so if you look at where solar panels are used, okay, what is the general trend of the world's PV installed capacity? Well, if you look at it, what's happening? Whoop, it's skyrocketing. Okay, it has increased absolutely every year, and it's almost an exponential growth. If you look at year 2000, we only had like 1,300, and now we are at 179,000 in 2014, and we're even further in this days. All right, so if you look at top countries that have installed solar panels, so how does the U.S. Installed PV capacity compare to others? So the United States, which is right here, or you could look at the map, is at about 12.9. So therefore, it is one. Germany's number one, China's number two, Italy's number three, Japan's number four, and the U.S. is number five. So what are some advantages of solar energy? First off, it's clean. You're not using any greenhouse gases. You're not emitting any of those. You're not doing the carbon dioxide. You're not doing any of that stuff. It is sustainable, okay, meaning that we're always constantly going to be having the sun as our source of energy, so you can reuse it. It is free. Nobody has ownership over the sun, and it provides electricity to remote places, so things that are not on the grid, you can still get electricity from. There are still some disadvantages. So first off, it is less efficient. Remember, the efficiency that we are running at about right now is 15 to 20%, and the equipment is extremely costly. In order to get solar panels probably on your house, you would need to be investing about $20,000 at this time. It's probably even about, it can go up to 30,000. If you look at those Tesla solar roofs where they actually have within the solar panel is actually within the roofing material itself, so you wouldn't need extra tiles or whatever. That you are talking about for a general house is about $70,000 in cost. So it is extremely expensive to do this. It is only part-time. What does that mean? Well, that means that you only have the sun for some of the day, some parts of the day, right? We will always have night, so therefore it is only part-time. Its reliability depends on the location. A desert is obviously much better than someplace that is in the shade and things like that. And then there is an environmental impact of creating these things. You have to mine the silicon, you need to mine all the equipment in order to produce these PV cells. So therefore you are doing some damage to the earth in order to create this energy. All right, hopefully you have an understanding of basic efficiency, how these solar panels are made up and arranged, such as the cell and then the module and then the array and the array field, and then some advantages and disadvantages of using solar energy.